Hello again, everybody. Now we will discuss section 1-2 in your book. This is going to start on page 13. So really for this one, what we're going to be talking about is distance or length. So you guys are familiar with the absolute value. Absolute value bars are going to represent the distance. So absolute value it will either represent the distance or length of something. And here, that something is going to be a segment. So if we have, let's say, a number line, and let's say this is at 4, and this is at -3, we want to find out how far or how long this segment would be in between here. So the way to do that, the distance, you're going to have the absolute value bars, and you're going to have the right point minus the left point. So 4 minus -3, and if you guys recall, when you have a double negative, you need to switch that to a positive. So it's going to be absolute value of 4 plus 3, which turns into the absolute value of 7, which is 7. So that would mean this to go from -3 to 4 is going to be a distance of 7. All right. The next thing we need to talk about in geometry is going to be the notion of congruent segments, or congruent in general. So congruent means equal or the same. Okay. Equal or the same. And in geometry, when we're talking about segments, we mark congruent segments with tick marks. So if these are the same exact length, then we will mark them with these little tick marks in the center of the segment. In this class, we're not really going to do much with constructions. So if you see something about constructions in the book, you can kind of avoid that. I'm not requiring you guys to have protractors or rulers or compasses, so we're really going to skip those parts. The next thing we need to talk about is between. So between just means somewhere in the middle. Somewhere in the middle. This is kind of a loose definition, but somewhere in the middle. Whereas the difference here, and this is a really crucial point to bring up, the difference here with midpoint is the exact halfway point on a segment. And also the bisect, to bisect something, bisect means to cut exactly in half. So when you think of midpoint, you should be thinking of bisect. When you think of bisect, you should be thinking of midpoint when you're talking about segments. Between just means it could be somewhere in between or in the middle of 2 points. It's more general than that. Okay? So one thing we want to talk about here is the segment addition postulate. So segment addition basically says if you have a long segment, let's say this is A, B, and C. If you have a long segment made up of A, B, and C, AB plus BC is equal to going the whole distance from A to C. So that's what the segment addition postulate means. And we can do an application problem of it just to kind of go ahead and practice with some math and some algebra. So let's say that we have a problem, example 1. Let's say that point B is between A and C. let's say that AC is equal to 14 and BC equals 11.4. Find AB. All right? So in this case, we need to draw a picture. So it says B is between A and C, so we have a similar formula for before. We have A, B, and C. B is between, so it's somewhere in the middle of A and C, not necessarily exactly halfway. So AC is 14, so that means this whole thing to go from here to here is 14. And to go from B to C is 11.4. And we're looking to find this distance right here, from A to B. So in order to do that, we're going to take this whole 14. We're going to subtract off the 11.4, which should give us 2.6 is the distance or the length of AB. All right. There's one more type of example we want to talk about here, and that is the example with midpoints. So let's say B is the midpoint. So this is example 2. B is the midpoint of segment AC. Let's say AB is equal to 5x and BC equals 3x plus 4. Let's find the length of AB, BC, and AC. So when it says find the length of all these things, it actually wants you to find like the number or the actual length. These here are now in terms of variables. So what we'll do is we'll go ahead and draw a picture again. So we've got A, we've got B, we've got C. AB is 5x and BC is 3x plus 4. Okay. Now the midpoint. Midpoint again means exactly halfway. So if this is exactly halfway, that means that these two things must be equal to each other. So what we can say is 5x must equal 3x plus 4. And this is a simple algebra problem. You can subtract 3x from both sides. This is going to give us 2x equal to 4. We can divide both sides by 2, and then you're going to get x equal to 2. This is not the length of any of the segments. This is just the value for x. Now what we have to do to find all of these lengths is we have to plug this back in. So AB is equal to 5 times what our value of x is, which is 2. 5 times 2 is going to give us 10. Over here, BC is going to be 3 times the length, or 3 times the value of x, plus 4, which is 6 plus 4, which is equal to 10. And then AC is going to be the sum of both of these, or 10 plus 10, which is going to equal 20. So this will give you the way to find if you've got a midpoint. This could also say B is the bisector of AC, or B is the midpoint. So remember, we can use the term bisector and midpoint interchangeably in geometry. All right, guys, I will be back with you for section 3.